Black holes are super weird. They're one of those things in space that really make scientists scratch their heads. They're crazy interesting because they suck in everything, even light, with their insane gravity. It's like, past a certain point with a black hole, the normal rules of physics just don't work anymore. Einstein thought them up way back in 1916 as part of his theory of relativity, but for a long time, they were just an idea. Nobody actually saw one until later into the 20th century. The big moment? In the 60s, some folks were looking at the Cygnus constellation and stumbled upon something strange. There was a bright, blue star shooting out a ton of X-rays. This star was orbiting something invisible, which didn't make sense. Turns out, it was locked in a gravitational dance with a huge black hole called Cygnus X-1. Finding Cygnus X-1 was a huge deal. It pretty much proved that black holes were real and opened up a whole can of worms for space exploration. Cygnus X-1 is about 6,000 light-years away from us, and it's a beast. It's super tiny but packs a gravitational punch so strong that not even light can escape. That's how it got its name, a black hole. Since then, we've found tons of black holes all over the universe. Some scientists think there might be over 100 million of them in our own galaxy, the Milky Way. They're hard to spot directly, because they don't emit light. However, space scientists believe to have discovered several potential black holes in our Milky Way galaxy. They come in different sizes, from stellar mass black holes made when big stars die to supermassive ones chilling out in the centers of galaxies. Black holes have a reach that goes way beyond their immediate area. They mess with how galaxies form and affect anything that gets too close. If something gets too close to a black hole, it's game over. It gets pulled toward the event horizon, which is like the point of no return. After that, it gets stretched and squeezed like crazy before being swallowed up by the singularity at the very center. This spaghettification thing is pretty wild. As something gets closer to the black hole, the gravity is so much stronger on one end than the other that it gets stretched out into a long, thin noodle shape. The black hole's forces are so strong, it easily overcomes the bonds holding the object together and breaks into fine particles. Even though black holes are awesome for testing the limits of physics, they're still a big mystery. Scientists are trying to figure out how they work and what they can tell us about space, time, and gravity. They're like silent guardians of the cosmos, always pushing us to learn more and explore the unknown. The closest black hole we know of is about 1,500 light-years away, which is good because, naturally, people wonder what would happen if one got too close to us. In 2021, scientists got the first clear picture of a black hole, M87, which is located in the center of the M87 galaxy. It was a major win. It gave us a way better understanding of what black holes look like and how they're put together. The pictures showed that black holes aren't just empty voids, Researchers identified 3 layers inside the image of the supermassive black hole. The outermost one is the event horizon, the point where there's no turning back. Once something crosses that line, it's gone for good into the black hole. Going inward, there's the photon sphere, where light gets stuck orbiting the black hole. Any light that enters that zone is trapped by the gravity. At the very center is the singularity, where everything we know about physics breaks down. The usual rules just don't apply. Each black hole has a unique structure and characteristics. That means normal scientific methods just don't cut it when you're trying to study them, so scientists have to come up with creative solutions. Because we can't send probes into black holes without them being destroyed by the gravity, indirect observation is still the main way to learn about them. Scientists are working on different ideas about how black holes are born and how they work, from stars collapsing to stuff happening between stars. NASA's research into the center of the M87 galaxy found some big clues about a huge black hole controlling things there. Even with all the difficulties, we keep pushing forward, driven by our curiosity and thirst for knowledge. Though the whole science and logistics of black holes are perplexing and confusing, scientists are hoping to demystify the riddle of the universe's big, empty, dark holes. Back in 1963, a researcher named Roy Kerr came up with a cool new idea about black holes. He thought maybe they could spin, which was different from what everyone else thought. His theory introduced this concept of the ergosphere. It described it as this region around a rotating black hole where space itself is dragged around with the spin, making it impossible for anything to remain stationary. Kerr's most interesting idea was this thing called an Einstein-Rosen bridge, which people often call a wormhole. It's like a tunnel through space and time, could connect far-off places. This theoretical construct connects two distant points in space-time, potentially allowing faster-than-light travel. The wormhole idea comes from Einstein's theory of relativity, which says that space and time are connected. Massive objects can warp this fabric, creating gravity. Wormholes would be like shortcuts through this fabric, making it possible to travel huge distances faster than you normally could. Still, whether wormholes are real and if they'd even be stable enough to travel through is a big question that scientists are still trying to answer. The dream of jumping through a wormhole to another galaxy is still just science fiction for now. The quest to find a theory of everything is what really pushes people's search for the fundamentals of the universe. At the forefront of this is superstring theory. Superstring theory tries to incorporate gravity into the quantum world, suggesting that the universe's most basic structures are not particles in the traditional sense, but tiny strings and their vibrations. These vibrations are what form everything that exists. According to this, the universe is like a big musical concert. The math of superstring theory gets really complicated because it needs more dimensions than the 3 space dimensions and 1 time dimension that we're used to. These extra dimensions impact our reality, though we can't see them. Although superstring theory is a really interesting idea, it's hard to prove it. Still, it inspires scientists and thinkers to keep exploring the universe. Even with all the progress, the mystery of quantum gravity and how it relates to black holes is one of the biggest challenges in physics, especially regarding all things regarding the supertiny and the supermassive. The whole field of black hole research is still super important. Black holes challenge our understanding of what's real and what's possible. Black holes help us understand the dynamics of stars and what is being active throughout the galaxies as a whole. The combination of black holes and a plethora of other space-related anomalies can help us understand the intricate dynamics of the universe. Black holes are seriously weird. They're one of those things in space that just messes with your mind, and scientists are still trying to figure them out. Basically, they're these objects with gravity so strong, not even light can escape. It's like, where the normal rules of physics just stop working. Einstein came up with the idea way back in 1916 as part of his theory of relativity. But for a long time, they were just a theory. It wasn't until the 1960s that we actually started seeing hints of them. Some space observers were checking out the Cygnus constellation and found a super bright star that was blasting out X-rays. This star was orbiting something invisible, and after a while, people realized it was locked in a gravitational dance with this huge black hole called Cygnus X-1. Finding Cygnus X-1 was a big deal. It proved black holes were real and kicked off this whole new way of studying them. Cygnus X-1 is about 6,000 light-years away. It's incredibly small but has a gravitational pull so intense that nothing gets out. That's why it's called a black hole, because it traps everything. Since then, we've found tons of black holes all over the place. Some estimates say there could be over 100 million just in our Milky Way galaxy. Of course, they're hard to spot, but scientists have a few candidates in our galactic neighborhood. These range from smaller black holes that formed when giant stars collapsed to supermassive ones chilling out at the centers of galaxies. Black holes mess with everything around them. If something gets too close, it's doomed. The black hole's gravity just rips it apart as it gets sucked in. They call this spaghettification, which is kind of a funny name for something so violent. As an object gets closer to the event horizon, the point of no return, the gravity difference from one end to the other is so extreme that it stretches and distorts the object, turning it into a noodle-like shape before it breaks down completely. It's like some horrible cosmic taffy pull. Even though black holes are super interesting, they're still a big mystery. Scientists are working hard to understand them because they could teach us a lot about space, time, and gravity. In the grand scheme of things, black holes are like quiet giants out there. They challenge us to go beyond what we think we know. We're pretty far from the nearest black hole, about 1,500 light-years. It may appear as a great distance, but we are anxious about its effect on us. Recently, in 2021, researchers got the first actual image of a black hole. It turns out it has some complex details that go against the simple idea of being empty voids. The picture, taken of the black hole M87 in the middle of the M87 galaxy, showed that they have layers. There's the event horizon, the point from which nothing can escape. Then there's something called the photon sphere, where light gets trapped and orbits the black hole. And at the very center is the singularity, where everything we know about physics breaks down. Each black hole seems different despite the general shape. That makes them tricky to study, and scientists have to get creative with how they look at them. Because we can't send probes into a black hole without them getting destroyed, we have to rely on watching them from a distance and figuring things out indirectly. Still, people are trying to unlock these cosmic secrets. There are different theories about how black holes form, from collapsing stars to interactions between galaxies. NASA's study of the center of M87 showed clear evidence of a supermassive black hole calling the shots in that area of space. While we still have a lot to learn, we continue to strive and advance our knowledge about the universe with our scientific quest. Back in 1963, a guy named Roy Kerr came up with this idea about rotating black holes, which was different than everyone else thought. He said there's this zone around the black hole called the ergosphere, where things can resist getting pulled in completely. Kerr's idea also suggested that there could be something called an Einstein-Rosen bridge, or a wormhole. This is like a tunnel through space-time that could connect different parts of the universe or even different universes. Wormholes come from the idea that space-time is this fabric that massive objects can warp. Wormholes would be like shortcuts through this fabric, letting you travel huge distances quickly, which means traveling faster than light, but Einstein put a cap on the rate you can travel inside space-time. Of course, wormholes are still just a theory and might not even be possible. Even if they are, the instability of wormholes prevents it. They have a lot of hurdles, and quantum things get in the way, but people still find them fascinating and a source of aspiration. The wormhole concept embodies cosmic entrances and realms, inviting people to explore the puzzles of life and new realms. The whole goal of unifying physics is to find one theory that explains everything. At the front of this is string theory. String theory assumes that the minute unit of the cosmic is not 0 points. It is a tiny strand instead. These strands shake as a string of a musical instrument. They shake at certain pitches. This makes particle and energy in the cosmos. The grand result of string theory is the features related to the holes and other outcomes that Einstein's equations show. Reality and abstraction mix, and truth lies in the balance. We face our principles of reality. Black holes and the cosmic link make the stars have dynamics that make our minds blown.